while the other people are taking their test, you are going to look ahead at the next section. So I am still in Unit 2, see, and now I'm in Part 4. So you all have this in your OneNote, Part 4. What I'm going to do is I'm going to give you the notes for it. And this is an Edpuzzle, so if you're not familiar with this, there will be questions as you go. You have to answer the questions to be able to finish the video. You will get a grade for finishing this Edpuzzle, and then it will set you up to do the homework. So I want you to do this Edpuzzle. Then I highly recommend to copy the notes into your own OneNote, and then you'll do the homework. So 3 things you should do: Edpuzzle, notes, homework. All right, so first thing we're going to do is we're going to take a couple minutes to practice graphing just to make sure you remember how, because most of what we're going to spend our time on for the rest of this unit is graphing. And if you're going to visualize a function, the best way to do it is through its graph. A linear function has degree 1, okay? Which means no exponents greater than 1. And its graph is a line. That's why it's called a linear function. We don't have to say a straight line. All lines are straight. So it is a line because it's a linear function. And it's a linear function because its degree is 1. Now remember, there are different forms of linear functions, like y equals mx plus b. That's a common form. That's slope-intercept. There's also point slope, and there's standard form. Now, when you think about lines, there are some special lines. Y equals 3, that's a special line. It is a horizontal line. We call it a constant function. Let's think about it. It's constantly the same value, right? Y is always 3. Now, why don't we call the graph of x equals 3 a constant function? I'm going to give you a second to think about it. Well, that would be because it's not a function. Okay? It is a vertical line, so it's not a function. Now, you do need to remember which equation is a horizontal line and which equation is a vertical line. So you may have heard this. If you had me last year, you did. Hoivux is a little memory tool that helps you remember that horizontal lines are y equals equations. H is for horizontal. O is actually supposed to be a 0 because the slope of a horizontal line is 0. And then y is for the fact that it's a y equals equation. And then the vux is for vertical lines. Their slope is undefined, and they are x equal equations. So that's a little memory tool you might remember. All right, so let's just go over graphing some functions that you should know how to graph already. And then we're going to go into a specific function today. So f of x equals -1. Remember, f of x is just y. So this would be a horizontal line at -1. Number 2, 2x minus 1 is a diagonal line, not a horizontal or vertical. So its y-intercept is -1, its slope is 2, and so it looks pretty much like this. And then x equals 4 is not a function, but it is a line like that. All right, now when we get into this one, x squared, notice that's no longer linear because it does not have degree 1. It, remember, is a parabola. And if you can't remember what it looks like, you can make a table of values. Make sure you include positive and negative values. Okay. It's very common to choose -2, -1, 0, 1, and 2, although those don't have to be the ones you use. And sometimes they're not actually going to be good ones. They may not be on your graph, or they may not be representative of your graph. But if you're not sure on what a graph would look like, you can always start with those numbers and see what happens. So here will be what we get for our y values. And so if we graph this, it looks like this. And remember, this is a parabola, so it is a U, not a pointy at the bottom, okay? And then here's one more. This one you should know from Math 2 is that parabola we just saw above, but it is going to be shifted left 1 and down 1. So here will be its vertex, and it looks like this. All right, but those are not the ones we're going to be focusing on right now. Those are ones that we need for later. For now, what we're going to be doing is we're going to be graphing the absolute value function. Okay, so the absolute value function, remember, absolute value is distance from 0, and that's why it's always positive, because when you measure distance, it's always going to be positive. So I have a whole list of x values here, and my y values, remember, if I take the absolute value of -4, it's just +4. And the absolute value of -3 is 3, and so on, so that I get these points. And my graph will look like this. Now notice this one actually is pointy at the bottom, okay? This shape is like a V, not a U, but a V. The vertex is at 0, 0. It is a minimum. The domain, since it goes far left as negative infinity and far right as positive infinity, that's its domain. Its range, it only goes as low as 0, but then it does go as high as infinity. Now, increasing and decreasing. You've got to understand what increasing and decreasing mean. You want to consider moving along the x-axis. And as you move along, you want to look up at the graph and see if it's coming down at you or if it's going up away from you. So as I come across here, notice the graph is coming down at me. So it is decreasing for that first part. Then as I continue, I see the graph moving up away from me. So your intervals that it's increasing and decreasing are intervals of your domain, okay? So this is over your domain that you have to give your answer as to where it's increasing and decreasing. So it was not increasing until I got to 0, right? And then it started increasing, and it was going to keep going forever, so infinity. Now we all know that infinity has a parenthesis, a soft brace there. But we got to talk about the 0 for a second. At that point 0, my graph had been decreasing, and when it got to 0, it turned and started increasing. So that is a turning point. That's a crossover point where it crosses over from decreasing to increasing. So we can't say the 0 is included because I can't include it in both. It's not increasing and decreasing at 0. So it's not included in either. And then it starts so that was my increasing. My decreasing started back at negative infinity and continued until it got to 0, and that was when it crossed over. Now notice the slope. For absolute value, you have lines on each side that meet at the vertex, and those lines have a slope, and that slope is important. On the left, the slope is -1, and on the right, the slope is +1. And then finally, end behavior. End behavior is asking what's happening on the left and what's happening on the right. So notice here, as x approaches negative infinity, that's how we read this, as x approaches negative infinity. So in other words, as we go as far to the left as we can, it wants to know what's happening to our y. Well, as we go as far to the left as we can, y just keeps getting higher and higher. So it's going to infinity. And then the next one, as x approaches infinity on the right. Okay, so it's going to positive infinity. So as x goes to positive infinity, which is as far to the right as we can go, y, again, goes to infinity. Okay? So I do want you to go back and copy this into your notes so that you can see it and you can write it. All right, now we've got one more thing we need to talk about, and then we'll put it all together. So the function y equals absolute value of x is a parent function. And then we can change it. Just like remember last year in Math 2 when we changed the quadratic equation or function? Well, now we're going to change our absolute value function. So we can do that by putting an a here, put a minus h here, we can put a k here. It should feel just like it did with the quadratic last year. And so if you recall, each of these causes something different, okay? So if a is negative, it will cause a reflection over the x-axis. Okay, so that it will flip, right? That's what we call it in Math 2. We say it's a flip. It's truly, technically, a reflection over the x-axis. But then also, that number is going to determine our slope. It'll be the slope on the right. And then the slope on the left will be the opposite of that, okay? So whatever that slope is on the right, it will equal your A. And whatever the slope is on the left will be the opposite of that. And truthfully, if we call it that, slope on the right, we don't even have to worry about this reflection because it'll be taken care of by having a negative slope. Okay, so on the slope on the right of the vertex, let's call it a little bit. All right, then remember if I have a negative h here, this is going, or a minus h, that's going to cause a slide left if you have a plus and right if you have a minus. And the k there is going to cause it to slide up if you have a plus and down if you have a minus. So if we just talk about what each of these transformations are, putting a +4 here will be up 4. And guys, this really should feel just like last year what you did with the quadratics. So number 2, if I put a +2 in the parentheses, that one's just going to go left 2. Number 3, now if I have a 5 in the front, okay, that will be a stretch, right? It's going to be a stretch. But now the slope on the right will be 5. And on the left then would be -5. And then the +1 will cause a left. Number 4 is going to be a reflect over the x-axis. That means it's going to open down. It's going to be flipped. Number 5 will also be a reflection. Remember, that's because of the negative sign. Because of the negative sign, it will reflect over the x-axis or flip. Means the same thing. And it'll go up 2. And then this last one, you're going to have a shrink by 1/3. And that will be the slope on the right. And it'll go right 6 because of the -6 in parentheses. So let's put this together, and then I'm going to have you practice. So number 1 here, I have -2, so that's going to be right 2. And I have +3, so it'll be up 3. So my vertex was at the origin. Now I'm going to go over 2 and up 3, and that will be my vertex. Then I look directly after my equal sign. That will give me my slope on the right. And since that's an implied 1, that means my slope on the right is 1. And on the left, it'll be the opposite of that, which is -1. And here's my graph. All right, so now we need to answer the questions that we just answered. The domain. Well, the domain will always be, for all of these, -infinity to +infinity, because it's always going to go far left and far right as possible. The range, it's only going to go as low as its vertex if it opens up. And so the range for this one will start at 3 and go to positive infinity. And it does include the 3. That's a solid point. It doesn't have any x-intercepts. The y-intercept is 0, 5. The vertex is 2, 3. That is a min. And then the interval that it's increasing. So this one, if we walk along, coming from the left, this graph will be decreasing. It's coming down to that point. So from negative infinity to 2, it was decreasing. And then it starts increasing at 2 to infinity. Remember, those are open parentheses. And it stops decreasing and starts increasing when you get to the vertex. But that's all from the domain. Okay, so that's from the domain. Because we're walking along, when I do this highlighter here, I'm walking along the ground, which is the x. All right, now the end behavior, all the way to the left, y is going up forever, and on the right, it's still going up forever. So what I'm going to do is I'm going to leave you now, and you will finish number 2 here and number 3 and do these problems, all of these. For a grade, you have the homework. So I will check page 17 for a grade. I do want you to do the other problems, and I will go over them if you have questions, but I'm not checking it. So you need to make the decision as to how many you should do. But you must do page 17 for a grade, and I will be checking that before our next class. So this Edpuzzle is due right now, but that's okay because you're finishing it. The homework is due before your next class. All right, have a great one.